Hi, welcome you all in the doubt clearing that video. This will be a very small video. So I got very limited number of questions from the group. So in compact way, I want to say that most of the participants they have asked that why that old structures are still now facing any problems. But even if we talk about the new constructions within some 5 years or 10 years, they need some maintenance or repair work. So based on this, I got two example as well in the group as well. This is regarding that Howrah Bridge of West Bengal and Eiffel Tower in Europe. So I want to show you that there is no structure which will not get deterioration or which will not distress after a certain time of that structure, or that you can also say that after some certain that life stage of the structure. So deterioration process is mandatory in any type of structure. It may be concrete or steel. And honestly speaking, or in a very big prospectus way, or in a very big prospective way, if you see, you won't find any steel which will not corrode. So I want to show you something regarding these doubts. I hope so the screen is visible to all of you. So so doubts from that Eiffel Tower. So you can also get the details in all those things in the internet itself. And Eiffel Tower is suffering from lot of that distress process. Even corrosion is also there, if you notice. And there is also a particular maintenance board. Those who are maintaining this particular that Eiffel Tower or that structure, that because you won't see all those the strains and that rust on Eiffel Tower, because it is properly maintained regularly. You cannot say that these structures are not that distressing, or these structures are not facing any corrosion. They are facing corrosions, because it's a process. When you will expose any steel structure or any steel in an open environment, it will corrode. So the quality of the material also plays a vital role in corrosion and the rate of corrosion. But if you see in detail, these are all the links, that last 3 points I have given. You can click on that links, you can find the detail that how the maintenance work used to be done in all these types of monumental structures and that important structures. So these links will give you the that some of the idea that these types of structures are also getting or also facing corrosion. So this is one that I'm going to show some picture of corrosion of Eiffel Tower. So this is the some of the evidence. I got all those things from internet. So I hope so you can also get all those things. So I got the details exactly from internet by web, by browsing all those things, because I got the doubts. I thought to show you some pictures so that you can understand that how much corrosion it may happen in old structure as well, that how much that devastating effect. Also you can see the picture in the left side that I can let me point. You can see that this is the picture I got from net, and this is also from the top of the Eiffel Tower. So the and special types of coatings are also used to be given. So if you go through I'm not going in deep of all those things. If you go through the link, you can find the different ways of that maintenance. That separate board is there who is doing all those coating works. Different types of special coatings are given, which can help the structure to withstand from various chemical reactions and environmental conditions as well. So if you see that I got a doubt, one participant asked me that how to know or how to understand the construction process, or the old techniques or ancient techniques of construction process to undergo a very long lasting structure, to have a very long lasting structure. So actually if you see that our historical monuments like as Eiffel Tower or Howrah Bridge of West Bengal, even Taj Mahal of Agra. So you cannot find any proper documentation how they did their work. So now if you see any project, they're having a proper documentation of both technical and from other perspectives also. So we have a proper documentation of work now. So if anything happens within this structure, we used to refer all those old documents, but it's not that much easy to get the techniques, because I think if you go through the history of our Indian monuments, you can find that even the workers, those who worked for that particular structure or for that particular monuments, were not supposed to disclose all those things, all those techniques that Rajas, Maharajas used to build all those structures, that historical monuments. They're not supposed to tell all the what that they are not supposed to tell to open or to release, or you can say to reveal the that technologies or whatever the things they used to get that much of good structure and long lasting structure as well. So one more thing also we have to notice that the environmental condition of that in ancient time and the environmental condition nowadays is not same. So when they have constructed this Eiffel Tower, you can take this as an example. They might not have thought that that the pollution or the environment will be changed in such a way. So this may be the effect of all those things. You cannot say that these structures are not getting that distress, or they are not suffering any distressing process. They are suffering. They do suffer from different type of that devastating effects, and they do suffer from corrosion. But the thing is, they are maintaining well, and they are maintaining regularly with a very good maintenance, maintaining that workmanship. And this is very important. We have to adopt a very good construction workmanship as well as very good repair workmanship also. So I got something that nowadays most of the concrete structures within some 5 years and 6 years used to suffer from a lot of that deterioration effect. I do believe in that, but I hope so. You all know about the that construction project works nowadays, how it undergoes, and the different stakeholders who are there in a construction project. What's the thing is happening? So so whenever we adopt some technology, and if the technology doesn't able to serve the purpose of it, we should not blame the technology. We have to see that what are the reasons that fail the technology to perform. So there are different types of reasons. That poor workmanship is there, materials, then a lot of blame games used to happen, a lot of other things I don't want to mention. You know very well what happens in a construction project, different government projects as well. So these are some these not maybe these are the reasons why we are not getting a good quality of structures nowadays. So if some X amount of budget has been sanctioned for a structure, but the amount used to become like X minus some amount. So we are not utilizing the exact amount which was has been sanctioned for a project. It may be any type of project. It may be some new construction, it may be some repair construction. And I have some examples where that the repair work has not been done, but the bill was passed and the things happened in such a way. It happens. We do believe in that. I also do believe in that. So this is also one reason for not getting a good quality structure. So one more thing, that in ancient times, the structures were most of the structures are made up of rocks. So rocks are generally natural source and natural elements, and they're having enough density, and that rigidity also they're having. So obviously the quality of natural products and the quality of artificial products will create a huge difference. I hope so. You know, you can understand the situation, or you can understand the reason why. This is also one more reason that because we don't have proper documentation. It's a huge research process to find out, because we cannot say, suppose now that any construction that is happening in nowadays, you can refer the documentation, or you can refer the documents, you can find out the techniques or technology they have used for constructing that particular structure or that particular that building or whatever. But if you say about the example, suppose take the example of Taj Mahal. So you can tell that what materials they have used, because it is visible. what technology they have used, how they did the work. So you cannot get the exact documentation. This is also one reason that we don't know that we used to say that civil engineering is a very ancient engineering. It is the first engineering that evolves in our civilization. But the technology the people used to used at that time, it's not possible to get because they didn't maintain any proper documentation. Even if proper documentation was there, but it's not available now. So it's a long-term research process. Being an academician, I will tell that that a lot of researches are going on across the globe. We are also doing a lot of researches to find out these things, what is happening. So one example, I forgot the name of the temple in Tamil Nadu. There is one temple near about of thousands years old. You can also get the data from by browsing. It's in Tanjavur. Tanjavur, one place is there in Tamil Nadu. So it's the age of this temple is like near 1,000 years. So a lot of testings are going on to find out that how this structure is still now intact without having any type of that cracks or something. So the whole, I visited the temple, but I now forgot the temple name because the name is somewhat it's big name. I forgot. The thing is, this is one question used to came in one of the that in one minds of students or in one student of VIT. So and like that, the different universities across the nation, they are doing researches on this temple. They are taking some samples of mortar or mortar in the sense that the bonding agents of in between the 2-3 rocks and all like that. From different places, they are taking these that samples or core samples like that by core cutting method. So they are doing researches to find out what are the chemicals or what was the chemical combination of the that particular that bonding agent. But after 1,000 years or after some 800 years or 900 years, it's not possible also to say that exactly what the chemical composition of the material was. So these are all the reasons we don't have any that perfect documentation or perfect idea that how the old work used to be done, so how they perform this work and how what type of technology they used to used at that time for constructing such structures. This is also one reason we don't know. So research that different researches are going on. So I hope so slowly. So this is a learning process. So if you keep on searching all those things, if you have a real interest in all those things to know, so you will slowly come to know of all those things. So so the message from this slide is that whenever you that expose any structure to open environment, so it will suffer or it will expose to distress or some that rusting or that deterioration method. So now again I want to show you one example from that Howrah Bridge. So these are the links you can get. You can get the details about the different mechanisms that distressing, that corrosion mechanism in Howrah Bridge, and it has been also decided or that to provide that FRP laminating in the base structure of the Howrah Bridge to prevent the corrosion. So these are all the links. If you go through these links, you can easily understand that these types of structures are also suffering from severe corrosion. So the reason of corrosion is the main thing. You have to understand the reason of corrosion. So in the case of Taj Mahal Agra, I hope so you people know that that there was a problem in the top dome of the Taj Mahal of the structure, that there was some archaeological people and some people found some that yellow patch or some yellow color patch over the top dome and some of the top side dome structures of Taj Mahal. So they did a proper investigation and they found that there are some chemical industries in near Agra and near that Taj Mahal. So these chemical that industries are exposing some that effluents and that harmful gases to the atmosphere, which is creating a chemical effect to the structure. So after that, government has taken a step so that the chemical industries may not expose this gas to the open atmosphere. Instead of this, that they can make some arrangements so that the gas comes into the water or other way to expose. So you have to find the root cause. So they have find the root cause why these yellow patches are coming. So they make a root. They have find out the root cause, and they come up with a very good solution without touching the structure itself. So that whatever the yellow patch they got, they have repaired, but further it didn't happen. So this small that repair work you have to do. Who knows, in that example that I given in the case of Tanjore temple, a lot of historical monuments you can find in our nation. India is very popular for all those things. So because whenever we see a structure, it's a very old structure. That's good. But to maintain the heritage of our country, or to maintain the heritage of that particular monument, we used to do a very good repair work. That repair work doesn't come to our eye in a normal way. We doesn't even that see all those things what people are doing to save all those historical structures. So whenever you expose the structure, it will suffer some problems. So in the case of Howrah Bridge, so that the root cause was a man-made cause. So it may be artificial, it may be natural, or it may be whatever. But in this case of Howrah Bridge, the cause was an artificial cause of that repair. So this is a very it's a very silly reason I want to share. The in India and most of the places across India, the people are used to have some that betel leaf type of things they used to take, which is known as gutkha or pak or something. So most of the people in Bengal, you can see the picture over there. They have they splitted over there the things that they used to take. So it used to have a high that acidic things, as well as some that lot of chemicals, that calcium carbonate is there, that lime and all. So it may create some that chemical reaction with the steel structure. You can easily see the that picture they have given. It is also available in the internet also. So for these types of structures, so now if I want to say in this case, suppose that in this structure they have did some that patching work in the sense they have cleared all those rust, then again they did some painting, suppose. So now again people will do like this, and again the structure will suffer the same problem. Now they have determined that this is a man-made problem. So they have determined that this is the main reason. So now they have uh, taken this action that no one should do like this. If you do, then we will fine. So like that they have mitigate this problem. So, and also due to the age, there is a corrosion. So to control the corrosion, they went to take a technology of FRP. FRP technology is very good because the polymer, the polymerization effect is there in the case of when we are talking about that fiber reinforced polymer technique. We are using some resins and all. So due to this polymerization, or due to this polymer, the polymer will have actually the polymer is having a high corrosion resistance. So this high corrosion resistance will help any structure to resist the corrosion. So if you want to know that in details about the corrosion mechanism, you can visit this website, the Vector Corrosion Technology. Lot of experts are there, those who are really having that huge experience to how to control or how to come up with a very good solution in various crucial corrosion situation and all those things. So I have shared all those that the link. You can go through this link to understand in detail about the different corrosion technology. So the name of the organization is Vector Corrosion Technology. You can easily find all those things in the web. So one more doubt actually I got that let me see this doubt. The doubt is steel coupler is safe or not. So steel coupler, yes, actually you can see I got some pictures, and whenever you are designing something, you have to think everything. Without thinking, you cannot take any type of design. So steel coupler is safe for both horizontal and vertical reinforcement. But in the case of horizontal and vertical reinforcement, that you can understand, in the case of horizontal reinforcement, the steel coupler will take tensile load. So you have to be very ensured that the grip in between the coupler and all, the grip should be very good. So because when you are using this coupler in the case of tensile reinforcement, so it will have a tendency to grip out back. So the gripping of this coupler should be very good in the case of tensile, and it is also should be very good in the case of compression reinforcement also, because it is going to take the load and it is going to transfer the load to the next that junction. So, and you have to be very ensured that that there should not be any ingress, or there should not be any that ingress of any that corrosion related that particles, or it should be sealed very properly, so that the junction or the coupling, that where the couple used to do, that couple should be very fresh. If any rusting or any stain happens there, so it may create a problem. So it's safe, you can use these things, it's safe. But everything in construction, if there is a practice of anything, all the practices are safe if they are maintained properly, or if they are executed properly. So execution and maintenance is a very, very important thing. So I will come up with some of the that things that you have requested. I will try to relate some examples. What the examples will be like, I will try to come up with example, like suppose how the work has been done earlier and how the work has been has been done now, the present scenario, the past scenario, and what are the differences and how the structures are failing nowadays in a very short time. So because it's a very detailed discussions, it is not possible to discuss all those things, because if you see that that one person have given an example of sulfate attack. So that if you want to resist one type of attack, it has, you can, if you see in detail, if you want to arrest something, then other opportunity or other agent will come, or other that channel of getting distress will happen. So you have to very ensure that you have studied the environment in which your structure is going to get constructed. So based on the environment, based on the environmental condition, based on the chemicals that are available across the throughout the ambience of the that construction site, you have to adopt materials and you have to adopt the designs. So part-wise video as well as webinar we will conduct in future. So this video or this webinar, the whole webinar was only to give out, only to give you an outline of all those things. In future, we are planning to conduct a part-wise webinar. So it will be easy also, and we can also discuss in detail about each and every particular topic. So I hope so. This doubt clearing video helped you somewhat to get some idea. And if you have further comments, you can do the comments. I hope so. It was useful. Thank you and have a nice day ahead.